All right. So today, we're going to continue to talk about this the shell that we've been looking at. Again, these are basically, it's called a Unix or Linux command line shell, an operating system. There's a bunch of different types of this operating system, just how like you have like a Windows machine and Mac, and there's different versions of OS. There's different Mac OS versions like Monterey, Big Sur. I don't know what are they on right now. They're on something else first. What California was that? Sequoia? Sure, Sequoia. Sequoia. So, and you know, there's different versions of Windows. I don't even know what Windows is on right now. Anyone know? 11. We're still on 11. All right. So, plus they need better names than this. Gotta give it to Mac. At least they have a little marketing advantage there. But so Linux, Unix, it's just an operating system. We use different types of shells, and I'll talk about that in a little more detail. But there are different kinds of, like, when you open that little terminal thing, there's actually like different versions of that thing. And we're just gonna learn one, but like I'll talk about it. But today we're gonna focus on making sure like we're good on all the navigation stuff. And this is like basic. We got to be able to move around, know where things are, understand how to figure out where we are. And then we'll start looking at things like operators. Hopefully we'll get to the point where we can start talking about regular expressions. And this will be one of the first places we can start to utilize like the commands of Linux to sort of start to do some of the examination of text and data that we want to be using. So one of the things where Unix is really powerful for is that you can write very little code and be able to manipulate files very quickly, right? Especially text files. So in a one term that's often used for this is called data munging. But you know, you can basically find ways to sort of process and extract certain things out of your data files very quickly. And regular expressions are a really important part about that. We use them in things like Unix, Linux, but you can use regular expressions in R and Python and any programming language. They're a common tool used by computer programmers and data scientists. All right, so we talked a little bit about some commands and what arguments are. We did a little bit of navigation. And I have a little exercise, but before that, I'm just going to review one thing with you guys. So just so we're all on the same page, I know you should have done the assignment last night, but just so that we're on the same page. Let's see, where is it? You gonna let me in? All right, so again, this is that Jupyter Hub, the Jupyter Hub, right? I'm gonna actually use this VS Code instance to do some of this work. So you could launch terminal and use terminal here. I'm going to use VS Code just because VS Code, I think in the long run, you'll like using this because it not only does terminal stuff, but you can also do Python stuff in the same spot. Okay, so it's a commonly used tool. We're going to use it here. If you don't see the terminal when you first come on, it's just here at the bottom of the screen. So you can actually just pull up this part and you should see terminal. If you ever launch VS Code and you don't see it, or you can go over to here, these three things, and you can launch terminal here. New terminal, right there. So two different ways to get at it. But we're going to use this one right here. Zoom in a little bit so you guys can see a little bit better. All right, so if I type ls, right? ls is list. We can see all the different files that we have here. We've got the file you should have downloaded from last class. This was on the Canvas site. We unzipped it from last class. We used a command called unzip, right? And remember, if I type W1 and hit tab, it'll just autocomplete the whole thing. So remember, I can use that tab to make sure I don't make any typing mistakes. It's going to unzip. And when I unzip, I should have ended up with this shell genomics directory. Okay. So ls is how I list and see what's there. Again, if I want to do a long list, I'd give it that ls-l. That's that use of that argument. And then if I wanted to navigate and change into that directory, I would use the command cd. And notice if I hit sh and I hit tab, nothing happens. I actually have to hit it one more time. It'll list anything that starts with sh. So that means if I want to autocomplete, I got to add another letter and it'll go. Now I can autocomplete to shell genomics. I hit enter. Now it shows me, right? I've moved my directory. I can see the new location that I'm in. Again, this tilde stands for the home directory. So now I've gone into my shell genomics data. If I wanted to see where I'm at any point, if I wasn't sure, I can always type pwd, and that'll give me the full path of the location that I'm in. And then if I want to see what's in there, I can see that there's a bunch of different directories and files here, right? So there's a whole bunch of information there. So I can also back up a directory. If I want to go back to my home directory, I can type cd .. Now notice I went from this directory into just the tilde. So that means I'm back in my home directory. If I type ls, you can see all the things that are originally in my home directory. Okay, so just want to remind you guys, we have commands that we're going to use in this case. We have ls. We want to see what we're looking at, where we are, what's in the directory we are currently in. pwd will tell us the location where we are. cd helps us move around, right? cd space, wherever you want to go to, okay? So if I want to go forward into a directory, I give it the name of the directory. If I want to go backwards, I do .. Right? So cd space, name of the directory, cd space, .. right? One goes forward, one goes backwards. So quick review. Should have been on the quiz too, but just to remind you guys, that's what we're looking at here. If you have, I forgot my stickies, darn it. If you have any questions about this, I just wanted to remind you about what they were. Okay, so that said, it's sort of just a quick starting exercise, just to sort of stretch out a little bit as we get going. I want you guys to move around in the hidden directory. So in that shell genomics directory, there was a directory called hidden. I want you to go in there and see if you can find a file called you found it. Okay, so you're gonna need to launch your Jupyter Hub, the iCore Jupyter Hub. Again, you can access that through the Canvas site. If you log on to Canvas, you can access that. If you don't have that file still there, you can download the file from there and upload it to the Canvas site. Up to the Cal iCore Jupyter Hub. So let me know if you have any problems. Try to open it up, see if you find a file. In the meantime, I'm going to run upstairs real quick and grab that too. There's my desk. Right back. Okay? Good? Any questions? All right. Be right back. What's up? Man?
We did A earlier. And to get out of that terminal, because we pulled up the file and there's just all errors. I'm like, oh, no.
So now you're Michelle. Nope, try to go in. Zip file. Try to go into Hills notes, so the new directory is.
So just manual stuff about this stuff.
The actual S8, or sorry, S. So if you just do SH, you know, the point over maybe not want to go back here.
Okay, and now it's like. Thank you.
You can always type out the whole name, which is like.
Yeah.
What's up, friend?
So,
Yeah, you go to Intel notes and you get hidden directory. Hidden directory.
Or that's, you don't want to see.
Yeah. So then you, now you can change directory, you go to hidden and look for the income. You're gonna have to sort of like take it down and. Okay, that's a lot. See that?
He's like a businessman. I'm in
Okay,
it.
so, but like,
It's, he said, look for you found it though, it hidden. So I think so. So he's. This is not it. And so did. Oh, yeah. So we're back in pins.
Nope, I just want you to know where it is.
It's another file, it's not in two. You found it.
Ah, you.
Of course, it's the last one.
Oh, you tried to unzip the file.
And then.
That's fine. He's already had it unzipped.
Yeah.
You're gonna have to do it. But if you walk up, you go, you just meet the-
Yeah, I'm writing down that.
So it's like, what's going up over right?
Yeah. Yeah.
Yes, it's. Put the blue one up and found it. So I know. We're located.
Here we go. He's like, oh, no child.
32.
Let's start going around here. You're gonna be really certain at some point.
When you have a problem, it's just all red, but I hear you. I hear you yelling at me. About
You're just gonna see me with like all my cup, like list of like, oh, my goodness.
I guess that.
Are you trying to get the other ones? Oh. You're gonna send this video.
I asked for help, how about? Yeah, I'll put up a, you go without my stress. You'll see. It can be there. Like if you, so.
When you say, wow, what a joke. You said, there's a joke with the file.
I guess it's a
We will open it.
Yeah, Robert showed me how to open it, so you take. Yeah, just do cat and add in the file. Oh. I'm sorry, Robert. I'm ready to forget. Okay, so.
Roger, do you have your thing?
I think I need it out. So you can read the rest of them. I'm following. Where'd you read? Oh, right.
Remember, if you found it, put that blue up, so I know that you're good. You have a question, put it up.
Okay, I'm kind of confused.
Yeah, you looked in, you looked in.
Yeah.
If you want to go another one, CD. You guys, my side is. I'm so available. So one, to get like the one height larger, you hit command the plus sign. Or control plus sign, depending on like your own back. So it kind of help, because sometimes we need to. Hiding. No, you wouldn't find it just. So. Obviously, you can surf through this side now, but see if you can find it using remember, you can use that tab. So you get stuck. We'll see. Kill whatever you want. In that case.
I just.
Yes, I guess yeah. Yes.
Oh, you know what happened? No. What happened is that.
No, Fisher?
That's the thought you were at.
Yeah.
Any of them have.
Oh, no. That one, that's it. What was it?
No, more, it's not. Verify.
This is not it.
I do like
Yeah.
First week of class. How's it going?
Oh, busy.
Tired already.
Got 17 minutes, so.
So are you busy schedule? We're all adjusting. We still have field season a mile out, so. We still have field experience. I never feel this sound, that's what I'm talking about. Grad students do next week. Grad students do this. Good stuff. That's great. Got some field work done, experience, I got 3-4 more weeks. Done. Good stuff. Nice to start, so. All right, both you guys feel like you're in a good spot? All right. Let's go over real quick where we're at. So a couple little things I just want to point out again. And you know, some of the stuff I'll remember as I do it. And sometimes when I do something, you might be like, wait, what'd you just do, Dr. Drew? I didn't actually see how you did that. So it's okay to ask, stop me. So like I said, if you want to make your text bigger on a Mac, you hit Control and then basically where the equal sign or the plus sign is, and that will cause your font sizes to grow. You hit Control minus, the command minus, it'll make it shrink, right? And on Windows, it's just Control plus or equal sign minus equal sign or Control minus sign. But it can be helpful because honestly, like it's hard to see these sometimes, especially when it's just like plain text like this. There are ways we can color code this text by using different shells, but I'm not gonna go in that right yet. So this is how we can go. Also, if you ever want to get rid of all the whatever's on your screen, like it looks like a mess to you, just type the word clear. And then it all goes away. And here's another, well, then I'll show you another trick in a second, which is also really helpful. So, I'm going to navigate into Shell Genomics, right? Shell Genomics _ data. And then once I go in there, if I type ls, right, I can see that there are, and I'll do a long list in this case, there's a bunch of different types of files and then some directories, right? So all these things that end in dot something, they have an extension. Those are almost always going to be files of some kind, right? So we got JPEGs, which are what kind of files? Images. SH stands for shell script, right? So this is actually like a little tiny program. PNGs are images, right? And then we've got MDs. Anyone know what MD stands for? Markdown, which is another type of text file. Okay. And then you got stuff that doesn't have that, right? And so these are typically going to be directories. Directories do not have extensions. A file can exist without an extension. It's a pain in the butt, but it can. But for most part, they will be. And actually, if I tried to go in to say like this hello, like, and I hit enter, it's going to give me an error message, right? Be like, hey, that's not a directory. You can't change your directory into a file. Like you can't move into a file. That's just not going to happen. So if I want to go into hidden though, notice that when I hit that tab, like I could just type it out like this and it would work. But when I hit that tab, it actually completes all the way to the slash. And that's one of those little tricks that can help you see whether or not it's actually a directory or not. Okay. So once it does that, I hit enter and now you can see, right, I've changed and now I'm in that hidden directory. If you look at where my present working directory is, I've gone from Shell Genomics data into hidden directory. Okay. If I want to see what's in it, I type ls. I've got 3 different entities in that directory. Temp1, temp2, temp3. Those are just different directories, 3 different directories, right? If I want to see what's in them, I can do that a couple different ways. Say the first way I could do it is I could change directory into temp1, right? And notice that if I just did T and I hit tab, nothing happens, right? I don't get temp1, temp2, temp3. And if I hit enter, it's going to be like, you can't change into temp because temp is not a thing, right? I have to be precise. So in this case, if I hit tab twice, it'll list what my 3 options are: temp1, temp2, temp3. So now if I just type a 1, now I can move into temp1. If I type ls, we'll see that now it's going to list the files that are there. These are not txt files, those are text files. So we can see not it, this is not it, this in not it. I don't know what that is, but but 2 different files. They're not the one. They're not the you found it file that I'm looking for, right? So if I want to navigate out of this directory now, if I want to look in another directory, I can back up, right? Now I'm back in my hidden directory. You can see I moved out of temp1, back into hidden. I can move into temp2, right? CD into temp2, type ls. I can see that there's another file, right? Now, I could back up another directory, or I could actually back up and I could go directly into temp3 using this relative path, right? I could actually just give it all in one step. I don't have to actually do it in 2 steps. I can just do it in 1 step if I wanted to. Because all CD is, it says I'm changing directory into this other location. So I can either change into 1 directory back and then CD forward into temp3, or I can just do it all in 1 step and say, hey, I'm gonna CD back and then go forward into temp3. And that's how I could enter it using a relative path. I could even get more tricky and I could say, hey, I could use, if I wanted to, I could use the full path, right? That would also get me. It's a lot more typing. Probably would never do this because it's just too much typing. But if it was me, I would either back up 1, then go forward, or if I knew that the next directory was there, I would just go directly into it. If I actually didn't know what was in that directory, like if I wanted to go back and I wasn't sure what was in the previous directory, like it was new to me and I didn't remember, I can actually just hit tab a few times and it'll list what my 3 options are. And then I can pick, okay, yeah, I want to go into 3. So these are just little tricks for navigating. When you're starting off, don't try to take all the shortcuts. Like, shortcuts are good. It's like when you play pool, like side pockets are for pros, right? Like you want to make sure you can make the easy shots first. So take your shots, like know the basics. And then as you start to get good at it, then you're like, okay, yeah, I'm going to speed myself up, right? But make sure you first know where you're going before you start going too fast. So if I type ls, I can find the file that I was looking for. Everybody pretty clear on how that worked? It's a nice little example of how you can navigate. If you take some time to try to play around in your file system a little bit when you get a chance, just see if you can figure out where you're going and where you've been. It's always a good thing. So just a few other commands that I was going to go over that I think were addressed in the video. There are ways that you can look inside of files, right? So this is just listing the files that are there. What if I actually wanted to look and see what was in a text file? There are a couple different ways to do this, okay? If I want to see the contents of a file. As long as they're text files, I can just print whatever information is to the screen, one way or the other, right? If they are like a Word file, which we refer to as a binary file, which means that it's got a lot more formatting in it. It's not just text. These tools may not work in the same way. So sometimes, like if you open up binary files, they look like a bunch of mumbo jumbo. So if you were to open this thing up, this thing's up, it'll be a bunch of nonsense in there. So if you were to open this thing up, you can use a command. There's a command called, sorry, actually I'll start with the cat. Cat's the first one, and cat stands for concatenate, right? But it basically just takes everything in your file and just prints it to the screen. This is not showing, yeah. So when this happens, y'all gotta tell me, can't see the bottom, because that's not cool. Yeah. So I'm not always looking behind me. How am I gonna, I need to get rid of these. Hide. What is this? How can I get rid of this? Sort of. Is it gonna go disappear? Disappear. Disappear. Come on, control panel. Man. I gotta be able to hide this thing, right? What's that? Tab. I just want to get rid of this, I want to get rid of this thing down here so you guys can see what I'm typing. Oh, there we go. I think it was just, it was waiting for me to connect to audio, so. All right. Hopefully that's a little bit better. Can anyone see the bottom of the screen? In the back? Y'all good? Okay. So cat is a way for me it prints everything that I opened that's inside the file to the screen. But if I actually like, sometimes files are really long and you don't want to just print everything to the screen, you can use a command called more. Okay. And more will just list everything to the screen. Now it goes right to this. It's just like acted like cat. But if what you're listing is longer than the screen, then it will allow you to scroll down. But the thing that's silly about more is that you only can go one direction. You can only scroll down. So it's like, what's the point of this? Right. So I don't really, except that I guess it slows the scrolling, but it's not the most useful of tools. Instead, I would use a tool called less. Right. And this was the one that was on the video. Less is more than more. So you always want to use less. I would say so. Less actually opens it as a file. You can actually do things like search for terms in files and all this other kind of stuff. Like there's a lot of things you can do in less. They're very useful, but it lets you actually scroll up and down if you want to. And then to get out of it, you hit what button? Q. And that'll help you quit less. There are some other ways to view files. Like if you wanted to be like, you know, super fancy, you could use a program called VI. This is actually a text editor. I would not encourage you to use VI because you can get stuck in VI pretty easily. But now actually, if I wanted to edit something, I could actually go through and say, you know, stuff like hooray for me. You know, I can add in stuff if I wanted to. To get out of VI, I have to hit colon. And then if I want to save my changes, I'll use the letter W. And if I just want to quit, I'll use the letter Q. So it's a little bit of getting used to. I would encourage you to really worry about VI at this point, but just want to show you that these things exist, right? Some point later in life, you can learn how to use them well. One thing I did want to say is that a really helpful component to doing all this work is, I don't know if you noticed, but if you hit the up arrow, right, you can find your previous commands. Right? So these are all actually being saved in your history. So I can go back and I can find different commands. This is especially useful when you start writing more complicated code and more complicated commands, right? So I can use the up and down arrow to kind of go through and find different commands that I would have had, right? And that can be very useful in the long run if you haven't necessarily kept a good record of everything you just did and you want to get back to it. If you actually want to see what's in your commands, you can use a command called history, and it'll list everything. right? It'll list all your commands that it's saved. And one cool thing you can do too is, sometimes you might just want to look at, now let's do it that way. I'll show you a different way to do it. But so history is a nice way for us to sort of go back and kind of chase down different aspects. I think that's all I'll talk about for the moment. Let's go back to our little presentation. Any questions about any of those things that I showed? Yeah, I mean, I think it'll go back like a few hundred commands. It might go back more than that too. I've never really looked to see how long it goes back, but I know that I've been able to pull back things that are pretty old before in the past, so I think it might even go past 1,000. I'm not sure. But that's until the system resets. So sometimes when you log off, it'll reset. Like if I take my computer and I like reboot my computer, it's gonna reset my terminal history.
Is there a way to like, organize the history differently, like if you're looking for something, like you did really early, but you do it by time?
Yes, you can, and well, not by time, but by line. And I'll show you some tricks to do that in a little bit. Anything else? All right. So we talked about full path, relative paths. So if you are in the directory, so temp3, so say you guys are in temp3, okay? Can you find another file.txt without changing the directory? How would you find this one? Let's just do this one as a thought experiment as a class, right? All right, so I'm in temp3, right? This is the directory I'm in. There's two other directories. Temp2, temp1, right? They all are in it. I am currently located here. How can I look and see what's in temp2? Space temp2. LS space temp2? No, that won't work if I'm in temp3. But you're on my track. Okay. So if I do LS here, right, it's gonna say what's in temp3. If I do LS space temp2, it's gonna say there's no directory in this directory called temp2. I like Gilead. Sorry.
But you have to go, dash
in dash temp2.
yeah,
Not quite the right syntax. Daniel? What's that? The relative path, which would be dot slash temp2. So normally if I have ls, it's just assuming that you want to list the stuff that's in that directory. But if you want to list something that's in another directory, you just have to tell it. So in this case, you said, hey, what's in temp2, right? Or if I want to see what's in temp1, I would do ls what? Dot slash temp1. Right? So this is the way that we could go back and find the contents of the spots really quick. Right? So as you start to learn how to do this, and you start to get a little more comfortable, you can see how it can be very fast. I mean, it's actually, it can even be even faster than if you are clicking through directories or something. Takes some practice. Initially, it won't be fast. initially, they'll be like, wait, where am I? But you know, you can use that tab button the whole time. Because if you do dot dot slash tab, 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 right, like hit tabs a few times, it'll autocomplete temp, and then it'll list the three options of tab. If I wanted to, if I'm in this directory, I'm still in, temp3, how do I list the contents of that directory slash user stuff? How could I do that? So I'm still here. Right? Go back to Shell Genomics. This is my home directory. This is the home directory. This is the root directory. Right? So this would be Shell Genomics. Jovian, home, root, right? And then this is user, bin. I'm in this directory. I want to list what's over here. What's the, how would you guys? Yep, I can just use the full path in this case. And it'll list everything right there. So here, I use the relative path. I gave it a location relative to where I am. Here, I just gave it its GPS point, right? That's what I could have done ls space dot dot slash 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 user slash bin. That wouldn't. Wait. Okay. All right. Questions? Try them out. Try all three of these commands out real quick, see if you can, see what you get out of the results. Yeah. Yeah, so bin is short for the term binary. Which is another way sometimes we refer to things in the program. So binaries are those that are been compiled into the program. One of the definitions of them. But those are all the programs you can look in user class bin, you'll often see things like less, the CD, yeah, or other things like that. Those are actually the commands. And those are actually also saying you want to get more complicated. Everything in there is actually something called your app. Right? So that is past. One is like occasionally, and another one refers to everything you can see when you're at a person. When you're at a prompt, you can see everything when you have it. All very like. This is the way. Mandalorian-ish. So, but you can see everything in your path. You can see it all there. All those commands are accessible and useful to you because everything that's in that directory happens to be viewable and usable. It's a sort of a more, I don't want to take too much time to go into it because it's like a more complicated concept, but you can add things to your path and you can remove things from your path. And eventually, if you get really good at Linux, a lot of people like to tailor, what programs are in their systems, and they want to have certain programs available and certain programs not. So they'll change their path. Yeah, it's highly, the thing about these environments is they're highly you can personalize them to a huge extent if you really want to. And that's good because if you're working you're doing a lot of work in a computing environment, that means that you get a lot of control and you can make it really efficient for what you need to do. However, there's a learning curve involved in this process, and it can sometimes take a little while to figure out all that stuff. But once you get familiar with it and understand the concepts, it can go a lot faster. So were people able to find where another file.txt was? Where is it? Temp2, right? So if you do this command right here, you should have seen that file listed. Okay. And then, like I was saying, when you guys listed this, you just saw a whole bunch of stuff, right? Yeah, those are all programs that you can use. So you might have seen things that you're familiar with. Cat, LS, MKDIR, like different programs are there. They could be there, they could be in another directory called bin/bin. It's also the place for those programs. All right, we're gonna take, I'm gonna show you guys how to do some other stuff with regard to creating files, moving files around, redirecting files, but well, before we do that, we'll take a quick break. All right, take a 10-minute break, get up, stretch, move around. Y'all have been listening to me drone on for long enough. Rest your ears. I wish that they would schedule my classes not over eating periods. Did you guys eat before you came?
I struggled on like 2 years, so
I know.
I had a class that I was like, and then I ate after that. And then I have this 3 hour lecture and then I have a 3 hour lecture 10 minutes after.
Ooh, 10 minutes after.
Yeah.
That's tough. Gotta bring some snacks. Yeah, you gotta bring more snacks. Yeah, they like always schedule me at like either 12 to 3, I feel like, or 6 to 9 or 3 to 6. Like it's like I'm always over an eating hour. It's like they just always want me to have students who are hungry. And like for me to be at a blood sugar level deficit.
Yeah.
It doesn't do any of us any. It is what it is. I had bananas before I did. Now I'm hungry. And we got 2 hours. For now. Yeah, what's up? Right, colon. You. Colon, and repeat. Yeah, I'll track it. Let's get in there, think it out. I mean, generally, like, I wouldn't, for this case, like, you don't really need to use VI because of how the hub is set up. I would just use VS Code, because then you can just open up files directly in a text editor and edit them. That actually has like the ability to like point out like where, like what different aspects of your code are. What's that? When you look at when you go to the Jupyter Hub, there is an option to open something called VS Code. So, yeah. And it'll well, so you shouldn't, if you launch the Cal iCore, like any file that you save there should be saved. If you try to make, changes, like if you try to upload a package or something, or some other piece of code, that may disappear, and you'll have to reload it up next time. But yeah, so here, it's just right here, VS Code, and this is the same program I said that you can install on your personal computer. It's a pretty standard, setup. So like I would just say like, you can use whatever you want. You just go through and pick whatever theme you want, kind of like dark. And then if you want that, we want that terminal, it's just right down here. Yeah. But this way you can actually go through and you can like open up files. So it'll open a text editor immediately. And the nice thing about it is like a lot of these things will be color coded. But you can also like, and I'll show you guys as you go through, you can actually like launch. You can launch a notebook editor as well, so it'll actually launch this thing directly, so you can do R code and Python code. Also, we haven't gone over anything. I'll show you guys how to use it. But if you're gonna, I would say like that's why I was trying to use it. In this thing, so I would use this terminal for now, because then it becomes easier to do all your text manipulations. Otherwise, it's kind of like using VI. I only use it when like I can't get to something else. I would not encourage any guys to start trying to learn how to use it at all. Like it was developed at a time when like nobody had like clicking ability. So who knows too, like the reasons why they decided to do what they do. So Nano. Actually, I think Nano newer. Nano actually I think might be older. And VI and Vim came after, but Nano has been adapted more, right? And there are more interactive ones you can use. There's Emacs, Nano. There's another one, but I'm not remembering off the top of my head. I basically like I learned one and I was like, I'm good. Like I learned one text editor. I was like, I don't need to learn another one because I don't have to learn another one. It's like a waste of extra space in my brain. Yes. Yeah. That's all they were. This is basically how this is like all your computers are this underneath all the stuff that you normally click on. That's right. But yeah, initially like everything was terminal. So even like when I remember, I'm old, I'm not that old, but But like when I was in college, this is before like there was a lot of like instant messaging and stuff like that. But we could still instant message over terminal. Right? So like we figured out we could do it over something called Telnet. And so like I went to school in Maine and a bunch of my friends were in New Hampshire and we would like chat that way. And it still worked. And a lot, so and then like the reason, that's actually one of the reasons why like tweets and things like that have like specific character limits. Is because they're using like really old infrastructure, basically, that like was set up to run for like 255 or 256 character kilobytes, right? Like there are reasons why like that they're all set up that way. And they're like totally historical and archaic and probably could be changed, but they're just locked into how computers were set up, so now people use it. Or at least that's how they initially used them. All right. So, oh, one thing I was going to mention, first time, man, everybody who filled out the survey, you guys all identified strongly as scientists. That's awesome. I think that was really cool. Everyone was a one. It's the first time I think that's happened. So very cool. All right. So where were we? Back here. All right, so just haven't really talked about this too much yet, but what you guys have been using, I've referred to it as a shell a couple times, just so you know. Remember we talked about initially that there were like these three different components to this operating system, right? The kernel, the shell, and programs, right? The shell's how you like put programs in. That's the actual terminal you guys are using. Well, there's different kinds of shells. And we're generally using a shell that's called a bash shell. If you were to look at the VS Code or the terminal interface, you look up here, right? And it's a little hard to see because it's little. But right here it says bash right there. That tells you like what kind of shell you're using. When you create new shells, you actually, well, they don't have it set up in this one, but you can actually set up different types of shells. So there's not just bash shell, that's just one type of shell. And the bash shell was created by a guy named Bourne, so it's the Bourne again shell. It's one of the most commonly used one. If you're using a Mac, you're actually using something called C shell. But you have to understand, programmers, we love puns and bad jokes, so they'll just keep coming. That's how we're using, and there are different types. There are other kinds of shells you could use. There are versions of this, like if you were to use GitHub, they distribute their own version of Bash. They're called Git Bash. And they have all this kind of tunes. Remember I said they can kind of personalize these things? That's what they do. They're all personalized in different ways. But the most common one I would say is Bash and C shell, because Macs use C shell. I feel like I'm doing a tongue twister every time I say it. And most other people use Bash. I'm going to talk a little bit next about I've introduced you some like simple programs, and I'll introduce you to a few more. And then I'm going to introduce you to something called operators, okay? And operators are how you write like CD and you launch a program and it does something. Operators are symbols that do something, right? So like you, instead of typing a series of letters, you're going to use like an asterisk or a block, or you've already been using like dots, right? Those are operators. And so these are just things that tell the kernel to do certain things. And those things can be mathematical, they can be relational, they can be logical, they can have all different types of functions. So some examples of things that include are stuff like this, right? Yeah. These little guys here, you might think that they are inequality statements. They're not. They actually do different stuff when we're dealing with Linux, and I'll show you what they do. I tend to refer to them just as carrots, because like that's how I like to refer to them, but you know, they have, I don't really feel like saying like less than sign, greater than sign. So, but they, generally we would refer to these things as redirects. They redirect information. And we can almost think of that with them as funnels, like they funnel things in the direction they're pointing. This guy right here, is a very useful operator. I'll go into more detail about it. Called a wildcard. Basically, it's just like you would think a wildcard would be. It can mean anything, right? When you use the asterisk, it could mean any number of things that you want it to. It's like in cards or whatever game you want to play where there's a wildcard. And I'll explain how that works in just a second. But that's what that is. That's we refer to that as a wildcard. So this is especially important when we're dealing with matching characters in queries. So what you'll find is that there's this concept of using a wildcard in all different kinds of queries, searches, or any kind of search where you're looking for something. You guys ever, like, any of you guys ever seen how people can write like really sort of more specific Google searches, right? So if you want to, you can Google it. You can ask AI to show you some examples, but you can write like really more specific. Like, hey, I only want to find searches that have this or this, but they could have any, you know, they only have these terms. So it's like this and this. So you might use brackets. You might use other things, but there are also wildcards. We can say, you know, I don't really care if it starts. It can start with any letter, right? And so I have a wildcard in place of where the first letter of the word would be, or something to that effect, right? So it's a common thing that we use in search, and I'll show you examples, right? So, but what we learn in Unix doesn't necessarily always apply. Like the syntax could be different if you're doing a Google search, but just keep in mind that the concept is still the same. So once you learn conceptually how to do it, then it's just learning how to do it in Google or Python or whatever you want to do, just not Unix. All right. Is it here? No, not this one. Too many windows open. All right. So there we go. All right, I'm gonna go back to my home directory. So one thing that I think is a useful thing to do in any situation where you're using a computing system is to set up an area, is to make sure your stuff is organized how you want it to be organized. Okay, because like we're gonna use a lot of different files, we're gonna do a lot of different things. If our file system is unorganized, or if you were running a scientific project and your file system is unorganized, it becomes very difficult to find the thing you want to find when you want to find it, right? So organization, coming up with a system that works for you is always a really good approach. Now I'm going to present to you a system that works for me, which is based off of things that I've learned that other people do. It's not the answer to everything. Like if you want to find your own system, there are other ways to do things, but I'll show you one. And this is not like the most complicated system, but we just want to be organized in our how we set up our directories, right? So the whole point is that we just nest things within things, right? So if we have a category of something, we keep it in there. So I'm going to create a directory, and I'm just going to call it Bio380. Okay. So if I want to create a directory, and right now I'm in my home directory, right? That's where I'm located. Here, I'm gonna start from scratch so that you can see. So I'm in my home directory, right? I'm in my home directory. I'm going to create a directory, and I'm going to call it Bio380. Okay. And so I'm going to use a command called mkdir. Stands for make directory. Pretty straightforward command. If I've done that, now when I list what's there, we can see I created that directory. Bio380. Okay. I know off the bat that I want to move these files. I've got a bunch of junk now because if I keep on adding stuff in here, it's going to get really messy. It's going to be hard to see stuff, right? I'm going to take this shell genomics directory, right? I'm going to move that shell genomics directory into Bio380. Okay, I do that. And now we can see it's disappeared. Right now it's in Bio380. If I change directories into Bio380, and I look and see what's in there, I can see I've got one directory, and that's that shell genomics data. So shell genomics is not going to be the only example data set that I'm going to be using during this class. So I might actually want to provide some additional levels of organization. So if I know that I'm going to be using a bunch of different example data sets, and you might not know this until you got your second one, but as soon as you got your second one, you might be like, oh, now I've got two example data sets. I might want to organize this a little bit more so I'm not just looking at a ton of different things all the time. I might create a directory called example data sets, right? I also believe it's really smart practice to name things exactly what they are, especially if you like might walk away from something, you might come back to it, you'd be like, I don't remember what that is, right? If you name things what they are, it will help you in the long run. So if I'm going to create another directory, I'm going to call it example data sets. Now, what do you notice about how I just wrote that? Well, I heard a bunch of people say something all one time. What was that? The underscores. Yes. No spaces. Spaces are not your friend in Unix. Avoid spaces. They are a pain in the butt. They are they're like special characters. Don't use spaces in names. It will cause your life to be infinitely more difficult. Okay? Never use spaces if you can. Now, there are a couple different ways to name things. Underscores are great to use, right? The other way is sometimes people use something called camel case, right? Where they capitalize every word. It's another great way to do it. Notice I just started with a lowercase word. The reason why I did that is I don't want to have to hit shift every time I start. So I'm lazy. Okay. So there's a couple different ways to do this. I don't mind the first time I do it, just doing example data sets. I'm going to keep it like that for now. You could use camel case. You could use this underscores to separate. There are some people like to use dashes. Whatever you like to do. I tend to shy away from dashes because sometimes those can also be like operators that subtract things, right? So I would encourage you to either use camel case or underscores. Those are usually pretty safe. All right. So now I've got two different directories. I'm going to move my shell genomics directory into my example data sets. Okay. And there we go. So if you haven't already started it, why don't you take a second to make a couple directories, make a Bio380 directory, make another directory to hold your example data sets. You can call it whatever you want, and then move your shell genomics directory into that directory. Okay. When you're done, just put up the blue sticker and I'll know you're ready to move on. What's up? So this is the challenging thing is when you need to, is there anything in it yet? Or no? Just a,
Yeah, it's just something.
okay. So if you just want to remove it, RM was the right one, but exception things what's common and do like that. If it's empty, that's how you do it. But I will actually, I was going to show you guys how to remove directory. Leave something.
Put it all, that's really pretty good.
RMDIR space and then.
I've changed the shell.
So if you type CD and hit enter, it automatically right back here.
Yes.
Once you get it made, you can say, put up those, give me a question. Yes. You ever wanna go to? And then you'll see. That's a shortcut, so if you bring it. Yeah, you don't have permission to write it, the director would call. You're not, you don't. That is the same, I just wanted you to learn, as long as you know that you can use the command. Yep, you can't, like, because of the interface, this is possible. If you were on a different interface that didn't have, it's not this interface, you may not be able to. And that's, yeah, as long as you know the command. I'll still be help. Leave the sit where it is. Got other plans to do. Directory is about the. So the good thing is, you know, hold on, that's not. Now maybe you're like this, that's why you do it again. I know sometimes it might feel like I'm making you guys do the same thing or simple things, so I want to make sure we're building those good habits. So that. A little bit comfortable. I'm saying well, I guess, maybe you learn something. I don't think Sue's on.
Yeah, because I look into it.
Yes. Yeah, make the example data sets directory too.
Wrong.
Slides up before class. Not bad. If I can. Do it right now. I feel like my computer's on its last leg.
Okay.
I mean, there aren't any unsafe changes.
Oh, yeah.
So just a heads up to you guys, I will try to remember to upload the slides before class, every class. But if I forget for any reason, like I did today, just remind me and I'll make sure they're up there. So sometimes I like not all the things check and so I'll forget something, but just give me a heads up and I'll make sure they're available. If I forget to like do something like load up slides or load up code from the previous class, like something like that. I also have had some computer issues recently, so it's kind of slowed some things down too. Like right now. There we go. All right, let's see. Back to that. All right, so everyone got that done, right? One thing I wanted to show you guys also how to do. If you have this set up, so we still have our zip file there, right? And I'm just going to show you this example. So if I unzip that zip file again, it's going to make another copy of that directory, right? That shell genomics directory. So it made another one, even though I moved it away, I unzipped this and it occurred again. So one thing that you can do, if you want to, if you ever want to get rid of something, is you can delete it. Now, I need to warn you that when you delete things in Unix, Linux, there is no trash can. It's not coming back. It's gone forever. Okay. So when you use the RM command or the remove command, make sure you really want to remove things. Okay. Now, a simple way to remove things is to use RM and then the name of the file. And if you do that, right, I'm going to go back here. I type ls, it's gone. It's not coming back, right? I'm never getting that zip file back. If I try to remove that shell genomics data, right, notice that it says I can't remove it. And I can't remove it because it's a directory. Okay. If I really want to remove it, there are two ways to remove directories. The first way is if I had let's say I had an empty directory just called test. Okay, so now I have this directory called test. If it's empty, I can use a command called rmdir. And I can remove that directory test. If I try to use rmdir on shell genomics, it's not going to let me do it because it's not empty. So you're like, well, why would I ever want to use rmdir? I actually don't know. I never use it because what's the point if it only removes empty directories? I mean, it's not really the most useful of commands, but you can use rm to remove directories as well. But the way to do it is that you have to use an argument. And the arguments you would use, this first one is an R. And the R stands for recursive. Okay, so it's going to go through and remove every single level of things within that directory. Often, there may be something in there that's a little bit ornery to get removed. To make sure you actually remove everything, I would add the F, which means you're going to force removal. So it's not going to ask your permission about anything. It's just going to force its way through everything. Now, when you do rm-rf, realize that that's the big boy, I'm going to delete everything command. So you want to be really specific about when you use it and how you use it. Because there's no coming back from rm-rf. There's no stopping it. It's forging through. It's not going to ask you for permission. It's just going to do what it does. If you're ever curious about the commands and the arguments that are associated with any command, you can use something called the man command to look at the manual. Okay, so I can use man rm, and well, there was no manual here. That's interesting. What if I do man less? They didn't install any manuals in this thing? All right, I'm gonna have to talk to Shane about getting manuals installed. But if I'll show you what it would look like normally. That's a mess. So if I was to use man normally, if I typed a command and I used man, it would look like this. Okay, it would give me a usage, it would give me instructions on how to use it. And one of the first things it shows, which is one of the most interesting things on a manual, just 1 second, is that it shows you the command and then how to use it. So here I can use arguments, right? So as I could do the command, then I can put some arguments in, and then I could give it a file or a location or a folder or something. So to give you an idea how to use the command. Yeah. You mean your how much information you have on your yeah, we're going to delete some stuff, and so that should remove it. Yeah. If we hit some, I'm not exactly sure. We might have to increase the size of some of our hard disk space, which is fine. As we get there and we run into problems, I'm just gonna have to request larger directories. I heard that they have unlimited space, so I'm not that worried about it. But yeah, we'll deal with it as we come along, but we'll delete some things as we go through. And if we need to get rid of stuff, we'll get rid of stuff. So just so you know, if you want to look at these manuals, you can just scroll up and down using the arrow buttons. And you can see all the different types of arguments you could use. So there's a -D for removing directories. There is, you can see the lowercase r, which is equivalent to the uppercase R, which is removing a file hierarchy. So in other words, removing everything within a directory, all the stuff that's inside of it. You can see the -F, which is asking you to remove files without prompting for confirmation. So it overrides if you really want to, it'll ask you if you want to remove this file, if you don't want to remove this file. So these are just different ways that you can better understand how programs work if you ever want to dig into it. So, and there should be a man, I'm going to talk to, I'll talk to Shane and see. I don't know if I see if I can get him to install manuals for us or not. There may be a reason why they didn't. Maybe somebody doesn't want manuals available for their classes. I don't know. But just so you know, most systems would have the manuals available to them. So in this case, if I want to remove shell genomics, I just do rm-rf shell genomics, and it disappears. So if you can, go ahead and delete that, the W1 zip file, the week1 zip file, and then delete the directory. You don't have to delete anything else actually, because I don't think you should have a shell genomics there. But if you want to practice it, you can unzip, you can run unzip again on your zip directory on this W1 shell genomics. So you could run this command and then run this command. Or you can just delete the zip file and be done with it. But don't delete anything else. Just the zip file. Just the zip file. Unless you create an extra data file, then you can remove that too. In the end, you should just have three things in your home directory. Bio380, share, or Bio380 and shared, I think, right? I don't think. So did you use the rm-rf shell genomics? Cool. One other directory that would be good to make, which is also often a common thing done in software development, is to make what they call a sandbox. So I'm gonna have you guys make a sandbox directory. And you know, you make why do we have sandboxes? Yeah, to play around in. We want to play in our sandbox, right? So sandbox is a place where you can just do a bunch of stuff, test things out, play around. Doesn't affect our other core processes or other stuff we want to save. This is a place for us to mess around in. So in the end, you should have a Bio380 and a sandbox and a shared drive. I have some extra drives. You don't need to worry about this stuff, but you guys should have these three. All right, so a couple of things I want to show you guys. We went over RMDR. Another useful command. So I'm going to go into Bio380, right? And I'm going to go into my example data sets, shell genomics, and then I'm going to go into this MySeq directory. So in the end, you can see that I've gone all the way into this MySeq directory, right? And you can also see that it's shown here as well. And if I look in this directory, what you'll see is there's a whole bunch of different types of data files here. Okay. I'm a geneticist. Sometimes we'll talk about genetics data. We won't just talk about genetics data because I know not everybody here is into genetics. But it's useful data. It's useful just as a way of looking at data. When we look at data, you just need to, as any data scientist, you should look at it agnostically as data, right? In the end, it always helps to know something about your data in terms of understanding it, but it also is just data. So, any good data scientist should be able to sort of like look at any type of data and understand what the rules are behind it and how it works. So if you're not a genetics person, it's okay. We will use other types of data in the course. But if you're not familiar with it, just try to learn the rules that are behind it. Okay. That's what you want to do with any kind of data. You want to learn the rules that are behind it. So if you've never worked in genetics, you don't understand what DNA sequences are, all that stuff doesn't really matter as long as you learn the rules of it. It's the same way where if I was dealing with spatial data, I might not always understand, all the intricacies of how people are coding things in spatial environments. But if I can learn the rules, I can use the data. Okay. Every data set, by the way, has its own rules and its own notations, its own abbreviations. You're always going to have to learn them as you're dealing with it. But this is a DNA data set. So I just wanted to show it to you. And one thing I just wanted to point out is like, as we go through and we look at a single file in this data set, right? If I use that cat command, which again just prints the contents of that data file to the screen, and I hit enter, you notice like it just lists through a whole bunch of stuff. And like it just looks like nonsense to most of us. Like any reasonable person would be like, I don't know what that is, right? We'll talk about exactly what that is in a little bit. But the point is, it just printed all to the screen and it looked kind of big. Like it went and listed a bunch of stuff. If I actually wanted to figure out how big this data set is, I can use a command called WC, which stands for word count, right? With the argument -L, which means it'll count lines. So I can use that to count how many lines are in my data set. So if I do that, I can see that there's 31,172 lines in that text file. Okay, so it's just a useful tool. You can use it with any file, any text file, to try to figure out how many lines or how big your file is, right? And then obviously we could look at the size in terms of like, kilobytes, megabytes, gigabytes, whatever, that too. But sometimes you actually want to figure out, okay, like how many actual lines of data do I have? How many observations or entries? Now, this is not 31,172 sequences, and I'll explain why that is in a little bit. But it is a way for you to start to get a sense of if you want to count things. And I think that's the most important part I wanted to show you with this WC-L command. It's a little bit small. Sorry about that. Hold on a second. Just want to make it big enough that you could see it. Oh, all the way up. So if you ever want to stop a command and it's going, you want to stop it, you want to kill it, Control-C. That's how you stop something. So again, this is the command right here, WC-L space name of the file. Okay, it could be any file name. WC space -L. Very useful command for counting lines. And your question before, Emma, was?
Oh, no, I never.
Since we're here, I will show you the first example of using an operator. Okay, so if I was to use the command cat on that same file, right, it's going to print everything to the screen, right? That's what cat does. And again, if you did it the first time, print all this crap to the screen. wasn't that useful. I actually wanted to know how many lines were in that file. So I said, okay, we can use that WC-L and we can write it again. Well, there's a way in Unix where you can use operators to accomplish multiple tasks in one line of code. This is actually one of the ways that makes Unix the most powerful it can be, right? Is that I can run multiple commands at the same time. So what happens is I run this command, right? It's going to print everything to the screen. I actually don't want to look at it. What I really want to do is count it, right? That's what I really want to do. So if I use this bar, what it's going to do is going to take the entire output of this and it's going to send it as input to the next command. So if my next command is WC space -L and I hit enter, what do you think I should get?
Just
31,172, right? And that's what I get. And like it's instantaneous, right? Like it's just right, boom, bam, done. Like I don't have to list all these things, I don't have to wait it all, it just goes super fast. And this is one of the reasons why Linux can be really powerful, is you can pass output from one command, the next command, next command, next command, hit enter, and you can get an answer super quick. This is a simple example, but they can get way more complicated. I once had a Linux command, a Unix command that was like a page of text to do one thing, but it accomplished a whole bunch of different formatting steps that I couldn't have done by itself. But it just kept taking output, passing it as input to the next one, and output to input, and output to input, and output to input, and it worked great. I could process like thousands of files very quickly. So it's one of the powerful things you can do in this, but this bar is how you do it, okay? And in case you didn't know, do you guys know where the bar is located? Shift, it's the button above your enter or return key. That's the bar, that vertical bar. So when you do things like this in Linux talks, Unix talk, it's called working on a stream. So in other words, like you're passing the information on to the next one, working on a stream. Did you have a question? Okay. Any questions about that? This is the first operator I'm showing you to do. An operator, again, is a symbol that does something. In this case, what it does is it takes the output from this command and it passes it on to this one as input. All right. Where were we? So some other operators that we have. I got lost. Where'd you go? There we are. Another really important operator that we have is the wildcard. Right? And I mentioned that one before. In this case, it's a good place for us to show wildcards. So here, right, we've got all these different files. Now, say I only wanted to look at files that end in FASTQ. I only wanted to look for FASTQ files. I want to see what they all were. I can type ls wildcard dot FASTQ. So if I hit this, if I enter here, what do you think it's going to list? All the files that end in FASTQ, right? In other words, the wildcard, it doesn't matter what's before the dot FASTQ. As long as it ends in dot FASTQ, it's going to list them all. Right? And that's what happens. If I wanted to go up here and I wanted to list everything that ended in FASTA, right? I can just change this and it's going to list the one file that ended in FASTA. Robert.
Wow.
F3D wildcard lists everything that starts with F3D. And what if I wanted, so I don't know if you noticed when you're looking at these files, but each of these files has like a identifier, and then there's an R1 and an R2. So all these sequencing files are all paired with each other. There's always an R1 and there's always an R2. So what if I only wanted to list the ones that were R1s? How would I do that? Yeah, I would do ls wildcard R1 wildcard. Right? And if I do that, I'm only listing the files that have R1 in them. Now, what if I wanted to count how many of those files there are? How would I do that? Bar WC space -L. And then I would know that there were 20 samples in the sequencing data set. Right? Because every sample had an R1 and had an R2. Now I can count, if I count all the R1s, now I know how many samples they are. Now you can see, like, if you don't know a lot about a data set, but I need to know some information about it, this is a quick way for you to like go through someone's data that you aren't really familiar with and figure out this information relatively quickly. So I just you know how many samples there are. Oh, there's 20 samples, right? I don't have to ask somebody or look at my file. I can do it real quick with a very simple amount of code. Got it.
When do you put the second wildcard after it?
Why did I put a second wildcard after here?
Yeah.
So I could have written R1 underscore 001 dash F FASTQ, but if I hadn't put anything after it, nothing else would have listed. Why is that? Because nothing ends in just R1. Because if I'm only putting the asterisk in front of R1, I'm looking for anything that ends in R1. If I put the asterisk on either side, I'm looking for anything that contains R1. Anything that has an R1 in it. That's the difference. So if I wanted to see if anything starts with something, then it would, if I wanted to look at anything starts with R1, it would be R1 asterisk. Right? So that's the trick that you have to learn with wildcards. So it also means that when you do this kind of querying and this kind of searching, if you do want to make sure, like, you know, if I had gotten 0 back, I'd be like, oh, I messed up. Something's wrong. Because I know I should get something, right? So that you do want to have like internal checks that what you code is actually giving you back something that's reasonable for what your expectation is. So in this case, you know, the fact that I got 20, I don't know that that's 20 just by looking at it, but I'd be like, oh, yeah, 20 sounds right. That's about right. You know, or if I had like 2 pages of it and I got back 20, I'd be like, ooh, so I probably did something wrong. Or if I got 100, I'd be like, oh yeah, that seems about right. Right. Until you get good enough where you know you're not going to make a mistake, right? It's always a good idea to keep like your common sense also involved in whatever process you do it. But this is how these wildcards work, right? And basically what it's doing is it's creating a list of all the things that meet that criteria of that wildcard. They either have R1 in it, that end in FASTQ, that start in F3D, whatever that criteria you choose to do is. Does that make sense how wildcards work? Okay. The last set of operators I'm going to show you how to use are used, and we call them redirects. So before I showed you the example where like we use cat to print something to the screen, and then we pass that information on for another program to do something, right? For WC-L to count. Redirect is a way for us to take that information and redirect it into something like a new file. Okay, so what I can do, so say I've got all these FASTQ files and I want all these R1s to go into one sequencing file, right? I want all of them into the same sequencing file. So if I want to do that, I could say, hey, I'm going to cat all the R1s. And if I counted all those, I mean, it's a lot of, it's like 609,000 lines of text, right? But say I actually want to save them in a file. What I can do is I can use this caret to funnel them in to a new file, which I'm just going to call all R1 seeks.fastq. So if I do that, all that information has now been entered into that one file, right? So if I count how many lines there are, there's 609,440 lines in that file, which is the same that I counted before when I printed it all to the screen. So now I've got that file. I can open it up. I can take a look at it. You know, I can put around it if I want to. I can do all kinds of things. There is another command. So say I wanted to add all the R2 sequences to that file, to that same file. Okay. If I cat R2s and I want to have it after all the R1s, I can use this double caret to add it to the end of that file. So that double caret basically means append. So it means to put at the end of that file. So if I hit enter, now if I count how many sequences are in there, it's double what it was before, right? Because now I've got all the R1s and all the R2s. So now instead of 609,000, it's 1,218,000. Because now I have all the R1 sequences, and then I have all their pairs, their partner sequence with it. So that there's all the R1s and all the R2s. If I had not included that extra caret, and I had just done it like this, just one caret, redirected it in the same way, what do you think is going to happen? What was that? Yeah. So now if I go and I look to see how many sequences are in there, notice it's back to 609,440, and that's because basically I overwrote the other file, right? So just know that like when you redirect stuff, if you just use a single caret, it'll always write and create. But that means if that thing already exists, it's going to create and overwrite. If I use the append, it'll add to the end of it. Now, there are carets that go the other way, right? There are carets that pass information into commands. We don't use those much. I'm just going to say, if you can first just get comfortable with using these ones, I think that's what I'd focus on. The other ones that pass information in are used less frequently. They are useful in certain instances, but for now, you can just ignore them. I think if you can focus on learning how to use wildcards, bars, and redirects in this way, then you'll get really far, actually, when your capacity to do things in Unix. Okay. So we got a little bit of time. I'm going to see if you guys get a little. Oh, you had a question, Liliana. Lilia.
Did you make the old ones?
Oh, hold on.
Is that what we did, like the cat and then the first caret, and then you made it like basically the file? Is that what that is?
Which one was the one that I did what?
The one. No, because I was just wondering how you got how you created all R1.
Yeah, so the first one where I created all the R1 sequences was this one, right? So I used the wildcards to only print the files that had R1 to the screen, and then I redirected that into this file. Okay. And if you counted them up, I ended up with 609,444 sequences or 44 lines in this file. Then, if I wanted to add all the R2 sequences to the end of that file, I did the same thing. I catted, but in this time, instead of R1s, I looked for anything that had an R2 in the file name. And all that information I appended with those two redirects in a row to the end of this file. And that's how I ended up with 1,218,880 sequences here. If I had only used one caret, it would have just overwritten it. And that's why this would have only been R2 sequences with no R1s. And I'll post my code with like comments so you guys can see it later too. You can go back and check this if you want to check. Gets a little complicated. And the thing is, I'm trying to teach you guys like kind of like basic words and grammar basically of this language. And then I'm going to ask you to like make sentences. So I'm going to ask you to like solve problems and make sentences. Like I'm going to make you try to communicate using basic words and basic grammar, right? And so these are just kind of like the building blocks that we're going to be using. So eventually I'll be asking you to think more creatively on how to do things like figure out how many samples are in a directory, move this file or count how many of these things are there. Like I'll be asking you how to accomplish tasks using it. But we're on day 2, so one thing at a time. All right, so that wasn't what I wanted. All right. Here's some little tasks that you can do. So there should be a directory called /bin in your systems. So if you want, you can navigate into that directory, or you can just do it using the remote or relative paths. But I want you to list be able to, find the command to list all the files that start with C. Right? All the things that start with C in that directory. And I want you to list all the files that contain an A. List all the things that end in an O. And then I actually haven't showed you these for the but if you get by that, you can try to figure out this one too. Kind of list everything that has either an A or a C. Let's see if you can figure that out. Okay, and we're going to be using wildcards. Okay, the whole point here is to get you to think about how to use wild. Let's see if you can do the top 3 using wildcards. The bonus, get first we got. Okay, well, I will. You can go back to this room then. This. So people. So take all that stuff, but I won't put it back. You can list, that's the thing, that's all.
I guess we can do that.
Yeah, using the, so this thing, stage. So, it's not even starting. So instead of, just start. I mean. See that he just.
The last one. That's what I just asked.
More of the fine. Think of the bottom. Out of the bottom. Oh, so you're gonna go to the bin directory, so it goes to MD. Sorry. One of the list everything starts. To the C, and then if you're happy to make it a. How ends of it, so. Oh. Yeah. Okay, so starts, so then start, you're the wild card. Yeah. That's actually. See if you can get the like, oh.
You said, you said, yes, it's not.
Okay.
Yeah.
Things that can keep. I think that's not. Yeah. Also that works. Well, what to count? There's a multiple ways.
Oh.
That has like.
It's
Well,
the.
there's like, that's the thing about it.
I think it's just one second. Look, let me see that. Oh, it's mine, that's what I got.
Yeah, they have. I think the correct answer, by the way, to this one, you should list 525 things. Well, you're a user slash. Right, what was it?
Yes.
You might have, yes, right. So. Yeah, your questions. Okay, so if you didn't want to change the boundary, you would, so you do the list and then the location of that.
Yeah.
But you actually want to pass these. Slash. Slash there.
Just do this arrow.
So that would be introduction, listen every. She's only the one listening to the site, sorry, Steve. That's where you, there could be a good space. Let's start. You can use that word count. Oh, you're trying to get the. Yeah, that's how you get rid of it. It's, so, we're gonna go, sorry. We've been managed to. So, Sorry.
I'll open it and you can crash it.
I would say,
That was one of them. One of them.
Yeah.
Do you mind?
I think I did.
Oh, you're doing it on the other group, so, yeah.
I like
This one,
Yeah, and I also like that it's just.
Oh,
oh yeah, so you just did work at taking.
I also like that I could.
So, we get our own. That's the way. Well, it's been good for start, it's not now. Experience. That is the bar. You can. So now, when it's not, you need to. Then. I got 5.5. Yeah, you can't create. That's all. Until you get out.
Oh, maybe it's both. Like, this is like that.
Yeah, that's right.
I'm wondering, is it both, they can take both, the seed,
Oh.
or is it?
What's that?
But then, would it make sense to also more than have both than that? Just.
Yeah, that, you like A and then C, that'd be one way to do it. You could write that file to your home directory. All right, so I think most of you guys have been able to get most of these answers, right? So I'll wrap it up here so we have a little, you guys got. You don't have to go right to the end. So we had LS, right? Listed everything there. If I want to have just the things that start with C. C asterisk C wildcard, right? Those are all the things that start with C. See things that we like, cats in there, clears in there, like things we've seen before, cut, curl, all important things. If I want to do anything that contains an A, right? Anything that contains an A, so anything, it's gonna have an asterisk on either side of that, so all these items have an A in it somewhere, right? They've got an A here, could end in an A, could start with an A, right? If we go up, things that start with an A. If I want to do something that ends in an O, asterisk O, right? So all these things end in O, echo, pseudo, who, etc. And then the last question was whether or not you wanted to find things that only had an A or a C. A bunch of you guys did this, which is one way to go about doing it. The one thing that is complicated for this one is like you get doubles wherever you have both A and C. So when you guys counted them, I think everybody ended up with like 635. So this is tricky. I wouldn't have expected you to know this, by the way, right? So I'm going to explain my reasoning on this. So this is actually how I would have done it, is that if you ask it to do it in this way, it's going to look for either an A or a C on either side, and then you only end up with 525 items. Now, I know that because I know that. Yeah, it's a bracket. You guys don't know that, right? So part of like, sometimes when we're asked to do coding stuff, you got to figure out how to do things. So before there was AI, I was like, well, you can look it on the internet, right? Like you can actually go and like Google, how do I search for one of these two letters in a list of things? You can ask it. You can do the same thing you can ask AI, right? Now, I will also say this isn't the only way to accomplish this task. This is just a way to accomplish this task, which is also an important lesson to learn when we do programming, right? And of course, like I wish there was only one way and there was always only one way because then it'd be easy for me to grade and it'd be easy for you to learn. But the reality of the situation is that these programming languages are far more flexible than just what, I can come up with, right? And so there's always going to be other solutions. There will be multiple ways to solve almost every single problem that we have, which is kind of how the world works, right? There's always multiple ways to solve all different kinds of problems and tasks that we have. Now, a lot of times it's like, are we doing it in the best way or the most efficient way? I honestly don't really care necessarily that it's the most efficient or the most elegant solution of how to solve programming issues. I mostly care that you guys can get to a solution. Because if you can get to a solution, right, then, and you know how you got to that solution, and you know that that is a solution that works, that's a huge first step, okay? Then you can work on the elegancy of everything else as you go along. But I do think it's important to understand why. Okay? So if you were to get this to this solution, if I asked you this question, like, why does it work? You'd be like, oh, well, the bracket means it could be either or, anything in the bracket, right? So it could be an A or a C or anything else I put in there. And because I have the wild cards on either side, that means that it's just anything that contains any of these letters that are inside the bracket. Okay? So that's how I would want you to think about it, right? That you would at least be able to know so that later down the line, if you had to use it, you wouldn't necessarily have to go and do the search and ask the thing. You would actually know it. You can evaluate it. And it becomes part of your toolbox for how you think about problems and solving problems and being creative. Because one of the biggest things I want you guys to be able to do is to learn some of these basic terms and tools so you actually can have a real conversation, right? So that you actually can talk in this language in such a way that you can be authentic in that time. So when I was in an undergrad, I studied abroad in Madagascar, right? Only about a third of the people in Madagascar speak French. Very few people speak English. I spoke French, so I had to speak French almost 100% of the time I was there. But guess what? only about a third of the people there speak French. The other 2/3 of the people speak their native language, which is Malagasy, of which there are 18 different dialects, right? And I tried to learn the official dialect because about maybe 60% of the country could speak the official dialect, right? Which is the dialect of the dominant tribe. But I got to a point where I could have a conversation with people in Malagasy. I could navigate in that country in Malagasy. Now, I couldn't have a deep conversation in Malagasy, but I could have a functional conversation in Malagasy. I could haggle for goods. I could navigate through medical systems, which I had to do a lot when I was in Madagascar because I was really sick. I had like dysentery, malaria, all that stuff. Right. So, but I could navigate all those processes because I learned the language well enough that, and I learned creatively how to use terms and expressions and hand motions and all the other things that I needed to do. Right. I was a beginner. Took me a semester to get to that point. I'm sure you guys can get to that point in this class with what you do, right? But it does mean that, like, yeah, it would have been great if I'd had Google Translate with me. Probably would have helped a lot. But guess what? There's not very good cell service in Madagascar even now. So there's a lot of times where I would have not been able to use those sorts of tools to accomplish what I want to accomplish. I had to still be able to use my own creative way to literally survive because I was super sick. So like, I'm just saying, like, you know, like there are times when it really makes a difference of your own ability, and you will also just grow in your ability to be great scientists and great employees and great leaders and all this other stuff if you're able to sort of develop this capacity for creative thought that this is just part of. Right? This is just one example. This class is just one example where you'll have problems. You'll have to think creatively on how to solve them. You'll have tools, but the more you can get used to that process, the better you will become at it overall in everything you do. So just keep that in mind as we go through. It's going to be a little clunky at first, but you're on your path. You're learning some tools. I'm going to post up the code that I have. I'll comment it for you today so you can use that as a reference as well. I will also post up another quiz for next Tuesday. Okay. All right. Any questions before I let you guys go? Yeah.
Yeah, it's gonna be specific to me, so how do I put the, like, the thing you put a word count?
Okay. So if, remember the word count was like the command. So it was a bar and then this command. You actually, the space on either side of this bar doesn't matter. But you do have to have a space after the word, after difference, before the argument. But it's actually, I put a space there because it's easy for all of us to read. Technically, you don't need to have a space. That's one place where it is written. All right. Have a great weekend. Labor Day weekend, 3-day weekend. You guys can relax.
Howdy, thank you. Have a good weekend.
Yeah, you too. Yeah, no worries. Yes, I will post all showed up.
Walk on your own.
You wanna chat at some point about stuff? Yeah. When would you like to do that? I think maybe. Sure, let me look at my schedule. And what time are you free? Free from 8 AM. Okay, close to the morning. All right, let me just find a time that works. Okay. And I'll send you a Google slide or something.
Yeah.
Sound good? Yeah, cool. It should be a long conversation, but I just want to make sure that we're all the same page and I understand. Okay, okay, thank you, thanks. You too.
So I just wanna go over what you do.
Yeah, totally. So, last class, we spent in, Zoom records fine. So, we basically went over like overall, not like preview items, so discs and basically the important skill set nowadays, the sciences, and some of this stuff. And then we talked about sort of how it's structured, and then I gave a brief introduction into like the platforms we're using today, like the Jupyter Hub and, some other things like that, and then a quick, we went over the first three commands, but a lot of them are the same ones that we used today. So basically, just like change direction, this, all that kind of stuff. So if you can go over the quiz and understand like what's going on in the quiz, you would understand sort of like the concept of like, yeah, see you later. Of what we did on. So take a, my suggestion would be, go over the quiz, right? Make sure you see if you understand it, and then depending upon how things go, like reach out to me, you know, we can talk about it some more. You can find a time to me, we go through the, you know, all the slides are up. And like I said, I'll try to get the extra piece.
Okay, did you have recordings for that day too, as well as today?
Yeah.
And where do I access
I'm
them?
gonna put them all, I'll put them all up on the case.
Like on the module?
Yeah.
Okay.
I'll do that. Yeah, no problem, and welcome back. Yes. Yeah, you're gonna be gone on the 25th, or whatever, is that right? Yeah. Yeah, no problem. Yeah, I'll have to check and see what the schedule is. If we happen to have a quiz or something like that, we'll just, you can take it at another time. We will reschedule by the time. Or if there's an assignment or something, we'll just figure out the deadline. I haven't looked exactly at that date, if there's anything assigned on that date yet, so, but we can adjust. We'll be fine. Okay. I don't know about if anything specific you need to prepare, well, as we get, so I'm not 100% sure, like, where we'll be in the class on that day. So as we get closer, like on that Tuesday, or even the Thursday before, a week before, just check in with me, and then I can give you a better idea. Just remind me, and then I can let you know. If there's something we have to- All right, yeah, no problem.
You know, I don't get to.
We're doing sleep or?
Doesn't it computer system?
We all have that. Well, we're gonna meet in groups. Next week.